We're starting a new chapter that's going to sort of be an introduction to geometry, and the beginning of this chapter is talking about squares and square roots because we'll need to use those when we are studying geometry. So let's start by talking about what a perfect square is. A perfect square is a square of a whole number. For instance, 1 squared is 1, 2 squared is 4, 3 squared is 9, etc. These numbers right here are called perfect squares because they're squares of whole numbers. Let's see if you can think of the first, let's say 13 perfect squares. I've just drawn the first 3 for you. Why don't you pause the video and see if you can write on your paper the first 13 perfect squares, all the way up to 13 squared, and then turn the video back on and check. Okay, so here's a list of the first 13 perfect squares. We've already learned the first 3 of them, but for instance, this is 4 squared, 5 squared, etc. So this one would be 13 squared. So I would expect in our class that you would hopefully memorize, I mean, you probably have most of these memorized anyway, but memorize up to the first 13 perfect squares. And then there are other ones that you should probably just know generally. Things like 20 squared is 400. See if you can guess what 30 squared might be. Think about what 3 squared is, that's 9, and then there'll be 2 zeros. Those kinds of numbers I would expect that you'd be able to figure out pretty quickly. The next idea we're going to talk about is something called a square root. And a square root of a number is one of 2 equal factors of the number. So you may have heard of what a square root is. For instance, if I take 3 times 3, I get 9. So if I ask what is the square root of 9, and the symbol for square root looks like that, it's called a radical sign. The square root of 9 is 3 because when you take 3 and multiply it by itself, you get 9. So 3 is the square root of 9. It's also the case that if you take negative 3 and multiply it by itself, negative 3 times negative 3, you also get 9. So you could say that negative 3 is also a square root. It's also a square root of 9. So you could say that 9 has 2 square roots, 3 or negative 3. I do want to point out, though, that this symbol, which is called a radical symbol, whoops, let's try that again, radical symbol, radical symbol. When I write the square root symbol and I ask for, let's say, the square root of 25, I'm really asking for the principal square root of 25. And the principal square root of 25 is the non-negative square root. So if I ask you, find the square root, let's say, of 36, you're going to tell me that's 6. Now that's a different question than if I ask the following. Let's say I say that I'm thinking of a number, and when I square my number, I get 36. So in that case, you might think, all right, what number times itself gives me 36? So you'll think of 6. So you'll say x could be 6. But in this case, x could also be negative 6. Because when I take negative 6 and square it, so if I take 6 and square it, I get 36, or negative 6 and I square it. See, because that's negative 6 times negative 6. That also gives me 36. So the answer to this is 6 or negative 6 because of the way I asked the question. If instead I asked you, find the principal square root of 36, there's only one answer to that. It's the non-negative answer, and the answer to that is 6. So it's all about how I ask the question. So be very careful about the instructions. Am I asking you what number squared gives me 36? In other words, I'm writing an equation, x squared equals 36, and I'm asking you to tell me what number I could be thinking of. Or am I asking you, tell me the principal square root, or the non-negative square root of 36. So the key is, in the instructions, have you been given the square root symbol, So in other words, has this square root symbol been given to you? And in case that's asking for the non-negative answer. Or have I not given you the square root as I did over here, and I'm just saying what number squared can give me 36? I also want to point out that negative numbers do not have a square root in the real number system. So if I ask you, find the square root of -4, there's no number that when you multiply it by itself will give you a negative. So in this case, this number has no square root in the real number system. Now you might say, well, aren't all numbers real numbers? There is actually another set of numbers. All the numbers that we've ever studied are real numbers, but there is another set of numbers called the imaginary number system, and you will learn about that when you get on to something like Algebra 2, and there's a whole world of imaginary numbers where actually when you can take the square root of a negative number. But let's hold off learning about that just now. That's for another time. Okay, I'm going to ask you to find the square root, each one of these square roots. First one is the square root of 49, and hopefully you know what number multiplies by itself to give you 49, and that would be 7. Now here I've got a minus sign. On number 2 I've got a minus sign outside of the square root. That's all right to have a minus sign on the outside. So first thing that you would do is figure out what the square root of 64 is, and hopefully you all know that that is 8. And then of course you have to keep the negative sign from the outside. I'm actually asking for the opposite of the square root of 64. On this third one, I'm asking for both the positive and negative. So hopefully you know that the square root of 121 is 11, and I'm asking for the positive and the negative. Now this does not go against what I said before, in that these symbols still are asking for the principal square root. So this square root symbol, or the radical sign, is still asking for the non-negative square root of 121, which is 11. It's just that I'm also asking right here, this is telling you that I'm looking for the positive and negative square root of 121. Okay, now I'm going to ask you to solve these equations. So let's look at number 4. I'm asking you, what number, when you square it, do you get 81? So if you think about that, I could square, really what you're looking for is what is the square root of 81? The square root of 81 is 9, but since I'm asking for all the numbers that when you square them you get 81, I could square 9 and get 81, but I could also square -9 and get 81. So there are actually two answers here. There is both positive or -9. And you can write, if you want to abbreviate it and write it that way, that's fine. Or you can write them separately, either way. So if you're asking here on number 5, what squared gives me 144, hopefully at this point you'd be able to say that n either equals 12 or -12, or you can write it in that abbreviated way we just did. Now the last one, number 6, it's saying y squared equals 80, and you can round to the nearest whole number. So what you should be thinking of is, okay, what integers or what whole numbers, what whole numbers have squares near 80? Well, we just did on number 4 that 9 squared was 81. The number below that is 8. 8 squared is 64, so it is closer to 9. So you could say that y is approximately equal to, and the way that you do that is with a little squiggly equal sign, approximately equal to 9 or -9. So there are still two answers there as well. In the instructions on the homework, it is going to ask you to estimate a square root, and then it also sometimes will ask you to use a calculator. It might say, using a calculator might help you. I'm going to ask you not to use a calculator. Instead, I either want you to round to the nearest whole number, or tell me between which two integers the answer lies. So for instance, for this one, number 6, you could have said the answer lies between 8 and 9, or between -8 and -9. Alternatively, you can just say it the way we did here. Y is approximately equal to 9 or -9. What happens when you have a problem like this? Find the square root of 0.49, or 49 100ths. So there are a couple ways to think about it. You might recognize that 49 looks awfully like 0.49 looks awfully like 49, and hopefully you know that 49 is the square of 7. So you might think it has something to do with 7, but you all know that 7 squared is 49. So it can't be 7, but it is something like 7. Take a moment, pause the video, and see if you can figure out how the answer might be related to 7, and then turn it back on and I'll give you the answer. So it turns out that if you multiply 0.7 times 0.7, look what happens. 7 times 7 is 49, and of course you have to account for those decimal spaces moved. So you have to move the decimal spaces 2 places to the left, and you end up with 0.49. So if you got that the square root of 0.49 was 0.7, that's exactly right. Let's try some more of these. These are a little bit challenging. So for the first one, think of, all right, so 9 looks a lot like, this one looks a lot like 9. And you know that 3 squared equals 9. It's not going to be 3 though, because 3 squared is 9 and this is 0.09. So it's going to have a decimal point in there. So see if you can figure out what that is. Again, 1.69 here looks a lot like 169, but with a decimal point. And same thing with the third one, there's a decimal point. So turn off the video, see if you can figure these 3 out, and then turn it back on to get your solutions. So in number 1, it turns out that 0.3 times 0.3, 3 times 3 is 9, and then I've got to move the decimal point over 1, 2 spaces. So here, 1, 2, and I end up with 0.09. So you might notice something here. If you look at both in the previous problem that we did with 0.49, if you count the number of decimal spaces here, we've got 1, 2 in the answer, in the square root, and we have 1 decimal space outside. Again, here on number 1, we have 1, 2 decimal places after the decimal point, and we only have 1 on the outside. Let's look here, 1.69. Well, it can't be 13. Even though 13 squared is 169, it can't be 13 because there's a decimal point. So what if we tried 1.3? So 13 times 13 is going to be 169, but I'm going to have to count the decimal points here, 1, 2, and I'm going to have to move my decimal points. 1, 2, 1.69. So notice that the answer here is 1.3. There were 2 decimal numbers and decimal places after the decimal point in the square root, and only 1 on the outside. So let's use that same logic over here for the 0.0004. There are 4 digits after the decimal point inside the radical. What if we followed the same pattern and took half of them on the outside of the radical? Let's try 0.02 times 0.02. What happens? 2 times 2 is 4. I have to count how many decimal spaces I need to move that decimal point. 1, 2, 3, 4. Let's try it. 1, 2, 3, 4. And I do end up with 0.0004, which is correct. If you had tried 0.2, because you thought, well, maybe it was 0.2, let's just try that up here. 0.2 times 0.2, well, 2 times 2 is 4, but I only have to move the decimal space twice to the left. 1, 2. So that wouldn't have given me enough decimal points, so that is not the way to do it. So you might be wondering, why are we studying squares and square roots when we're doing a unit on geometry? Well, there are a lot of formulas that you need that require the use of square roots. For instance, if you have the formula for, let's say, area of a circle. I don't know if you're familiar with this, but the area of a circle is a equals pi times r squared, where r is the radius of the circle. We haven't learned this yet, but I'm just bringing this up because in case you're wondering why we need to know about square roots. So let's say you were given the area of the circle and you needed to find the radius. You would need to take the square root in order to find what r is. And in the homework that's going to be associated with this section, you're going to need to use a formula that looks like this. D equals 1.22 times the square root of a. And this formula is to estimate how far you can see from a point above the horizon. And in this, D is the distance in miles. That's the distance in miles. And A is the altitude or the height in feet. altitude or height in feet. So that will be part of the homework assignment that's associated with this lesson.